Hello viewers, welcome back to 𝒂𝒚+, and to this lesson we are going to solve these two examples under linear differential equations of first order ordinary differential equations. And if you are not subscribed to this channel, consider subscribing so that when a new video is being uploaded you'll be the very first person to be notified. So example 1, and it says show that y of t is equal to 𝒂𝒚+𝒕 minus 3 on 2 is a solution of the differential equation y prime is equal to 2y plus 3. So the whole idea here is that we want to show that or prove that this differential equation has a solution as 𝒂𝒚+𝒕 minus 3 on 2. So given the differential equation under discussion as y prime is equal to 2y plus 3, we first have to substitute the value of y, that is y of t is equal to 𝒂𝒚+𝒕 minus 3 on 2 in the differential equation, and we know the answer. And again we differentiate the solution, and then at the end if we realize that their answers are the same, we can conclude that y of t is equal to 𝒂𝒚+𝒕 minus 3 on 2 is a solution of the differential equation y prime is equal to 2y plus 3. If not true, you conclude that y of t is equal to 𝒂𝒚+𝒕 minus 3 on 2 is not a solution of the differential equation y prime is equal to 2y plus 3. So if that's the case, then we take it from y of t, of which you can write it as y is equal to 𝒂𝒚+𝒕 minus 3 on 2. We substitute it in the given differential equation. So when we substitute, then we have y prime is equal to 2y, but we know y to be 𝒂𝒚+𝒕 minus 3 on 2, and then there is 3 here, so we add a plus 3. Our solution continues, and here we can see that our y prime is equal to 2 multiplies 𝒂𝒚+𝒕, then we have 2 𝒂𝒚+𝒕, and then minus, so this 2 cancel that 2 and we left with 3, and then we add the 3. So it means y prime now is equal to 2 𝒂𝒚+𝒕. So we can call this as equation 1. Having known that, we also take it from the solution of the differential equation, that is y is equal to 𝒂𝒚+𝒕 minus 3 on 2. So from here what you are going to do is to differentiate this solution. If we end up getting the same answer as this, then we conclude that yes, it's a solution of the differential equation. If not true, we also conclude. So from here we differentiate, which means y prime now is equal to, this is an exponential function, so to differentiate we first differentiate the powers or the exponent. So when I differentiate the exponent 2t with respect to t, I have 2 and I multiply it by the function itself, so that gives me 𝒂𝒚+2t. When I differentiate a constant, I get 0. That is 3 on 2 is a constant. When I differentiate, I get 0. So it means that my y prime is equal to 2 𝒂𝒚+2t. I call this as equation 2. And clearly we can see that equation 1 is the same thing as equation 2. Therefore, we can conclude that y of t, which is equal to 𝒂𝒚+2t minus 3 on 2, is a solution of y prime is equal to 2y plus 3, indeed a solution of it. So now therefore we conclude, so we can say that since equation 1 is equal to equation 2, we conclude that y of t, which is equal to 𝒂𝒚+2t minus 3 on 2, is indeed a solution, is a solution of y prime is equal to 2y plus 3, 2y plus 3, and this becomes the solution of example 1. Now having known that, we proceed with example 2. And at this point, if you have not subscribed to 𝒂𝒚+, kindly spend a moment to subscribe, and we continue with our solution. So example 2 says that find the constant a, b so that y of t is equal to t plus 3 into bracket multiplied by 𝒂𝒚+𝒕 is a solution of the IVP, that is the initial value problem, y prime is equal to ay plus 𝒂𝒚+𝒕, giving the IVP as y of 0 is equal to b. So it's the same idea as we did in example 1. So we take it from here, so write our solution, and the given differential equation here is y prime is equal to ay plus 𝒂𝒚+𝒕. Remember that in this case you want to find the value of what a and b, but it's the same process. So here what are we going to do? We are going to consider the solution of the solution of the differential equation, that is this, and then we substitute it in the differential equation. So we can see that from the solution of the differential equation, y of t, of it the same thing as y, is equal to t plus 3 multiplied by 𝒂𝒚+𝒕. We substitute it into the differential equation. So our solution continues, and here it means that our y prime now becomes a multiplied by y, but we know y to be the same thing as into bracket t plus 3 multiplied by 𝒂𝒚+𝒕, and then from the differential equation there is plus 𝒂𝒚+𝒕, so we add it, that gives us plus 𝒂𝒚+𝒕. So our solution ends here for this. So let's call this as equation 1. So let's call this as equation 1, and again we consider the solution of the differential equation, and the solution of the differential equation was given us this one, so we consider it and then differentiate. So if that's the case, then it means that again from y, which is equal to t plus 3 𝒂𝒚+𝒕, what do? We differentiate it. So it means when we differentiate, then we have y prime to be equal to, these are two functions multiplying, we have t plus 3 as one function, and we have 𝒂𝒚+𝒕 as another function. So to differentiate, we apply the idea of differentiation by product rule, which means first we maintain t plus 3 and then we differentiate 𝒂𝒚+𝒕. So since it's an exponential function, the differentiation now becomes, we are differentiating the exponent. So when you differentiate the exponent, it becomes 2. Remember, we are differentiating with respect to t, so we have 2 multiplied by the whole function, that is 𝒂𝒚+𝒕. That is the first part, and then we add it to, so we differentiate t plus 3. So in differentiate t plus 3 with respect to t, we now have 1. Now 1 multiplies 𝒂𝒚+𝒕 maintained, that is 𝒂𝒚+𝒕, which implies that our y prime is equal to, since multiplication is commutative, we can rewrite this as 2 multiplied by t plus 3, and then we have 𝒂𝒚+𝒕, and then when 1 multiplies it, we have plus 𝒂𝒚+𝒕. So we can now call this as equation 2. Now, because we are interested in finding the value of a, we compare equation 1 to 2, and with that we can get the value of a easily. So we can see that by comparing equation 1 and 2, we can see that y prime from equation 1 is the same thing as y prime from equation 2, but after the equal to sign there is a in equation 1, but after the equation equal to sign there is 2 in equation 2, which implies that a is equal to 2, but the rest remains the same. So now we have the value of a now. So that is that, but we have to proceed to find the value of b as demanded by the question. So to find b, let's write here, to find b, we again consider the solution of the differential equation, that is y is equal to t plus 3 multiplied by 𝒂𝒚+𝒕. Remember from the question it said that the initial value problem of the solution of the differential equation is y of 0 is equal to b, so we make reference to that. So in our solution, remember that from the IVP said y of 0 is equal to b. So from the solution already, we can also remember that it was given as y of t, and y of t is the same thing as y, so we can write the same thing as y of t. So if I write y is the same thing as y of t, because this y is also a function of t, but here I chose to ignore the t, but here I wrote the t, so they are basically the same thing. So if that's the case, then it means that wherever I see 0 or wherever I see t, I write 0 from the solution of the differential equation. Wherever I see t, I substitute the value of 0 because it's the same thing as the IVP. So it means that y of 0 will now be equal to, there is t here, so I have 0 plus 3, and then e2, there is t here, then I bring my 0. But the IVP said that for every y of 0, we should substitute the value of what? B. So in here, for y of 0, I write b, which is equal to, now 0 plus 3 is the same thing as 3, and then e expo 2 by 0 is the same thing as e expo 0, and then we know that any number exponent 0 is 1, so 1 multiplies 3 gives us 3. So now I have a to be equal to 2, and then I have b to be equal to 3, and this becomes the solution for a and b respectively. So therefore we can say that a is equal to a is equal to 2 and b is equal to 3, and this becomes the solution to example 2. I believe we understand everything. So there are more examples to this. You can check out the next video after this so that we get to understand ordinary differential equation very well, and then the differential equations as well. So thanks for watching. Kindly like, comment, subscribe, and share. Remember that this is 𝒂𝒚+𝒆²𝒕. We are thinking beyond infinity. See you in our next video. It's bye bye for now.